Now we are using the binomial theorem plus expansion and application. This is the second topic for A2 levels. We know that binomial means bi means two and nomial means terms. So there are two terms in this expansion. And we write this formula as a plus b power n is equal to a power n plus nc1 a power n minus 1b plus nc2 a power n minus 2 b2 plus nc3 a power n minus 1 n minus 3 b3 and so on till b power n. But at that time, we have imposed a condition for this there that n should belong to a positive integer there. So this is the basic formula for this binomial theorem. Or we can convert this formula there. A power n, nc1 is basically equal to n into a power n minus 1b. nc2 means n into n minus 1 divided by 2 factorial into a power n minus 2 b2 plus nc3 means n into n minus 1 n minus 2 divided by 3 factorial a power n minus 3 b3 till bn, and here n belongs to all real numbers. Whatever is the value there, it can be used for this part of this formula there, binomial expansion. Now we know that NC1 basically it is basically equal to NCR, that is equal to n factorial over r factorial into n minus r factorial. If we write NC1, it should be equal to n factorial over 1 factorial n minus 1 factorial, which is equal to n factorial over 1 factorial is 1 into n minus 1 factorial. And this is equal to n into n minus 1 factorial divided by n minus 1 factorial. This thing is equal to n. And the same way we can proceed it for the rest of the calculation. This. Now we have this formula for a2 1 plus x power n, where a is equal to 1, b is equal to x, and n is as it is there. So this will be written as, according to this formula, b part of this as 1 plus nx into n minus 1 divided by 2 factorial into x square plus n into n minus 1 n minus 2 divided by 3 factorial into x cube and so on. So this is the formula which are going to use in this part of A2 levels wherever the binomial theorem is there. Now, if we have to apply it, one plus 2x power 4. So it should be equal to 1 plus 4, n is 4 there, and this 2x is equal to b there, where a is equal to 1. So 1 plus 4 into 2x plus 4 into 3 over 2 factorial into 2x whole square plus 4 into 3 into 2 divided by 3 factorial into 2x whole cube plus 4 into 3 into 2 into 1 divided by 4 factorial into 2x power 4, which is equal to 1 plus 8x, 4 threes are 12 over 2, 6 into 4. So that is 24x cube square plus 4 into 4, 3, 2 and 3 factorial, 6 and cancel out 4, 8 are 32x cube. This and this cancel out, so it should be equal to 16x power 4. So this is the first application with the simplest form of that in the form of 1 plus x power n there. Now, for this application, we have the different examples where n belongs to the all real numbers. So we have this example for this portion, 1 plus 2x power minus 3. But one thing I should tell you in the beginning, that whenever n is an integer, when n belongs to this integer there, then positive integer, then they have always finite terms. And when n belongs to all real numbers, then it will have infinite terms there. So here n is minus 3, which is not a positive integer, but it is a real number. So it has infinite terms there, and we can use for this formula for the application of this. So where n is equal to minus 3, b is equal to 2x, and 1 is equal to a. So we can write this thing as 1 plus minus 3 into 2x plus minus 3 into minus 3 minus 1 minus 4 divided by 2 factorial into 2x whole square plus minus 3 minus 4 minus 5 divided by 3 factorial into 2x whole cube and so on. So we can write this thing as 1 minus 6x. This is minus minus plus. So 3 fours are 12 over 2, 6. 6 fours are 24 x square. This minus plus and this minus again minus. So 10 into 8 is 80x cube and so on. Now we can use this as 1 plus 2x power half. Here n is equal to half. This is b there and this is a there. So it should be like this, 1 plus half into 2x plus half into half minus 1 divided by 2 factorial into 2x whole square plus half minus 1 half minus 2 divided by 3 factorial into 2x whole cube there. So this will become equal to 1 plus this 2 and 2 cancel x there. Then half into minus half into 1 over 2 into 4. So that thing is equal to minus sign there. So 1 over 2x square there. Then we can use this half into minus half into minus 3 over 2 into 8 divided by 6. So 3 2s are 6, 2 2s are 4, 2s are 8. This cancel out. So minus minus plus, and it should be 1 over 2 x cube and so on. Third, 1 minus 2x power 1 over minus 2. So here n is equal to minus half and b is equal to minus 2x and a is equal to 1. So this can be written as 1 plus minus half into minus 2x plus minus half minus 1 divided by 2 factorial into minus 2x whole square plus minus half minus 1 minus half minus 2 divided by 3 factorial into minus 2x whole cube and so on. And we can write this thing as equal to 1 minus minus plus 2 to cancel. So 1 plus x plus minus half minus 3 by 2, 4 over 2. 2's are 4 and 4 cancel. Minus minus this plus 3x square. Then this minus half minus 3 by 2 minus 5 by 2 minus 8 divided by 3 to 6. So this is minus 3, this is 2, 2 for the 2, the 8, cancel out. So here it is left minus 1, minus minus plus, minus plus, negative plus. So it will be plus there. Now 1 into 5, 5 divided by this 2 and x cube to that. This is the first video for this binomial theorem, and we will proceed it further for the second video with the different examples.